If anyone wants to watch this here up on the board, this is 7.7 from the review for Chapter 7. This is number 9. So I've got the question and I've got the solution from the solution manual here beneath it. So we can take a look at both at the same time. So a radar antenna is located on a ship that is 4 kilometers from a straight shore. So we've got a straight shore here. Oops, let me get my highlighter out. We've got a straight shore. There's the shore. And the antenna on a ship is located 4 kilometers right here from the shore. Here's the ship. That's the antenna. And we have 4 kilometers. Okay, so we've got a 90-degree angle here. The shortest distance from the antenna to the shore is at a 90 degree. Here's the shore. The antenna, okay, so it's picture this big thing that's rotating. It's rotating at 32 revolutions per minute. Okay, so yeah, I feel like this is a question that we haven't really gone over yet in class, and I missed Friday. So yeah, I can't remember if I've done this example with you. Anyways, so the angle. So when it says something is rotating like this, right? That's going to be the angle. So think about this. It's shooting its sort of like signal. It's rotating. Doesn't matter which way. But it's rotating at 32 revolutions per minute. So that's 32 times 2 pi radians. So that's 64 pi radians per minute. Now that is the rate of change of the angle. So that's theta prime. Okay? So how fast does the radar beam sweep across the shoreline when the angle between the beam and the shortest distance is pi over 4? So now what you have to think about is this. Let's say it's not going this way. Let's say it's going this way. The beam is rotating kind of this way, okay? And so it's shooting a beam here. This is the shortest distance. Then it's shooting here, 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 here. See? And so on. And as you can kind of tell, it'll kind of like sweep along faster and faster and faster as it moves away. And then it'll shoot out here, and then it'll come in here really fast, and then kind of slow down, and then go faster. See that? So the beam is sweeping along the shoreline, and the shoreline is a straight shoreline. So what we need to find here is x prime. That is how fast this is sweeping along the shoreline. Okay? Now x prime, x would be like the opposite side of this right triangle. So you've got an angle. Now this is really messy. But now you've got an angle, and you've got x over here, and then we're trying to find x prime, the rate of change as it sweeps along the shoreline here. Okay, so you've got a right triangle, you've got an angle, you've got opposite side, you've got adjacent side. Okay, so right away, opposite and adjacent should tell you that we've got some kind of tan relationship. So tan of theta equals x over 4, right? Or x equals 4 tan theta. You good with that? So since x equals 4 tan theta, the derivative of that is going to be 4 secant squared theta prime. And then once you get there, you can insert your pi over 4 and evaluate. And you should have about 512 pi. And that's going to be the units of distance per the units of time. Okay? I'll let you think about that for a second. If you have any questions, you can let me know.